Hi everybody, welcome to another HD DWF arcade repair video. This is the third of 4 Zaccaria Galaxia game PCBs that I got to be serviced. If you haven't watched the previous videos about the other Zaccaria arcade PCBs that I've really published, you may want to pause this one and watch them first, since a lot of the information and details on the test setup will not be repeated in this video. You'll find the relevant links in this video description. Now, this board had a big label attached over its Signetics 2650 CPU. This label, written in Italian, says that the integrated circuit has a broken pin. And indeed, we can see it in this picture. Further inspection showed that also some of the EEPROMs have broken pins, like this one. And this one with 2 broken pins. On this other one, the pin is broken right as it exits from the ceramic case. This is the only one that's not so easily fixable anyway. We start by gently removing all oxide layer from the remaining part of the pin with a small file. Then we apply a bit of solder on it. And then we solder a new pin taken, for example, from a failed IC. And last, we trim any excess length. This is the final result. Not bad. Similarly, I attached new pins to the EEPROM that had 2 broken ones. And this one is the other EEPROM that had 1 broken pin. When the pin is broken too close to the IC case, things get complicated. First, we obtain a pin from a donor IC that we cut right as it exits from the case, so it ends with an angle. As before, we clean all oxide from the remaining part of the pin, and using a lot of flux, we try to solder the new pin over the broken one. When the pin is short, it's usually needed to raise the iron temperature a lot to have a good joint, since the ceramic case is a decent heat conductor. Notice also that the resulting pin is shorter than the other ones in this case, but it will still make a good contact on the socket anyway. However, this EEPROM also needed reprogramming, since the content I could read was not good. After erasing it with the ultraviolet eraser, however, it would not program correctly. I tried a few erase cycles, and I've always got a verify fail after every programming attempt. So maybe the excessive heat applied during repair made this EEPROM fail, or it was bad from the beginning. In any case, I've got a SPAR 2708 to go in its place. The other 2 repaired EEPROMs could be read correctly, by the way. This board has an EEPROM set partially different from the previous 2 boards of the same game that are already repaired. As you can see on this image, the EEPROM label has B/N written in the top left corner. That in Italian means black and white, so probably for some reasons this PCB was used in a cabinet with a black and white CRT. Two more EEPROMs have the same indication, and they are the ones containing the aliens in the formation and all other static character shapes. All other EEPROMs add already known dumps. And by the way, a sticker in Italian recommends installing the black and white memory set. Another issue evident from initial physical inspection is a missing Signetics clock and synchronism generator, the S2621 in position 12C. Of course, I don't have a spare one, so I would borrow a chip from another PCB. If and when this board is repaired, I'll tell the owner to order a spare IC. Another thing I noticed is that this PCB is marked as 1B1132/0, which is a different revision with respect to all the other Galaxia PCB I received, since they have a /1 code. This looks like an earlier version of the game. And another quite evident problem is shown here. Transistors Q1 and Q2 are entirely missing. Only part of their pins remains, and transistor Q3 has also broken pins and cannot be soldered back. Q4 is unpopulated even on the other PCBs, by the way. For now, I have removed the broken pins and I will install new transistors only when all the rest of the board is functional. These transistors are only used to toggle the coin counters and bonus counters in the cabinet. This capacitor was mounted with two long legs. I'll just trim the legs and solder it back in its place to avoid it moving too much and touching other pins. This other capacitor must have been hit at some point. I think it now measures about 60% of the original capacitance. However, it will be substituted with a spare one. Now let's observe the other side of the PCB. We notice some bulge wires and trace corrections, but that makes sense since this was an early revision, maybe the very first one of this game. Here are some more bulge wires, one cut trace under one of the yellow wires, and a capacitor soldered right under a chip. More wires, and another capacitor soldered right under a chip with a broken leg. This last one was in a bad enough shape that I decided to substitute it instead of just soldering back the leg. Oh, and by the way, the sliced capacitor is indeed measuring about 64% its original value, that was 100 nanofarad. Anyway, I replaced that capacitor and installed a borrowed sync generator IC in the 12C socket position, so we can finally power up this board and see what happens. Looks like the screen flashed, and then nothing else happens. So let's check first the reset signal on pin 16 of the CPU. It's stuck high. Something is wrong for sure. Now, just a quick reminder, on the S2650 CPU, the reset signal is active high, so a stuck high signal on pin 16 means the CPU never starts executing code. The reset circuit on this game PCB is rather peculiar, and during the past repairs there were no needs to actually troubleshoot it. I have checked diodes and transistors before the first power on, as I always do, and none of them had any obvious fault anyway. Initially, this circuit puzzled me, but then I decided it could not really work without CN7 pin 1 connected to 5 volts. And here we can see why. The leftmost LS14 inverter gate at 13C has its input pin number 1 permanently grounded by R5, so its output on pin 2 will be permanently high. This will keep D17 into conduction and polarize the base of transistor Q4 that in turn will keep its collector almost at ground level, and that is connected to the second LS14 inverter gate input pin 3, so the corresponding inverter output will stay high, and that goes to the CPU reset pin. Let's see now what happens if instead CN7 pin 1 goes to 5 volts. In this case, capacitor C2 starts at 0 volts and charges via R88 resistor, so the first LS14 gate will have a low input, then a high input after a certain delay. Its output will then start high and turn low after the delay. When pin 2 of the LS14 is low, D17 does not conduct anymore, and the base of Q4 will then stay grounded by R91. With no base bias, Q4 will then be off and allow C86 capacitor to be charged by R89, making another delay, after which finally the output of the second LS14 gate will go low, allowing the CPU to start executing code. So let's check if on a working board R88 is indeed connected to the 5 volt rail. And indeed it is connected to the 5 volt rail. However, on this /0 PCB it seems not connected. So I'll jumper the resistor to 5 volt and let's try again. So far so good. Now the reset goes low. But we don't have any clock signal anyway. However, if I try to move the clock generator IC on its socket, here is what happens. So I've substituted the socket in position 12C. Now the game boots, but it's quite unstable and crashes often, like we can see here. So let's try my diagnostic ROM. Well, it did not find any error, and the ROM checksums are also correct. Anyway, the game keeps on crashing in a random way. So at this point I decided to change all the ROM sockets like I had to do on the previous boards. The original sockets are extremely unreliable. Unfortunately, after substituting all the ROM sockets, the game remains stuck on the screen, but at least it is not randomly crashing anymore. We can observe the fuel level slowly decreasing, so the CPU is still executing some code, but for some reasons it's always displaying the screen. Actually, my test ROM cannot test the 2636 video ICs, so I suspect the defect is related to them. Interestingly, one of them seems never accessed. Anyway, I've just swapped 3 non-good S2636 and the game starts and runs without getting stuck anymore. However, notice how diving aliens sometimes disappear and have erratic behaviors. Anyway, only one 2636 was actually faulty and causing the game to never start. Since now I'm sure that all the three 2636 ICs are good, as I tested them on the other boards, I decided to substitute all of the 40-pin sockets too. These 40-pin sockets had gold contacts, but as you can see, the springs don't close completely anymore, and that can make unreliable contacts on some pins. While I was removing the sockets, I've also noticed this capacitor that had a value quite different from the other boards. This is C84 and adds a small delay to the clock input on the three programmable video generator ICs, so I thought it could be related to the alien erratic behavior, and I decided to install the same value indicated on the schematic and present on all the other boards. And since the CPU socket was of the same type, I decided to substitute that one too. However, this PCB still has some subtle defects. Observe how the diving islands disappear randomly and reappear later in the wrong spot or over a static alien in the formation. I've made a little video compilation of the fault. Since I could not find any evident fault in the various video circuits, I started really suspecting some timing issues on the various clock signals. One thing that pushed me in this direction was the different capacitor value on the clock PVI signal that I had just changed. However, watching clock delays between the faulty board and a good one did not really give me any good hint, since it's really hard to tell on what point of a capacitively loaded signal an IC will toggle its inputs. So in the end, the signal comparison was as long as unfruitful. So I decided to pause troubleshooting this issue for a while and took some time to see what differences this black and white ROM set would make on the black and white signal output of the game PCB. These video clips are taken one from a regular Galaxia ROM set and the other from the black and white ROM set. You can tell which one is the black and white ROM set since it's running on the Diving Alien glitching board. You decide whether or not the black and white ROM set did really make any difference. I started comparing all the added small capacitors on a good working board to the ones that were installed in the problematic Revision 0 PCB. This one, on a good board, is a 330 picofarads on pin 9 of 13B clock divider IC. This capacitor, by the way, is not even present on the schematic as far as I can tell, and yes, the schematic has an error. That 74S112 IC is not in position 12B as written, but it's on 13B. However, the same added capacitor on the Revision 0 board that was actually mounted on the solder side has a different value of 1 nanofarad. So I have substituted it with a 330 picofarads ceramic capacitor as the ones installed on all the other good PCBs. However, diving aliens still randomly disappear and reappear as you can see in this video clip. The other big difference of this revision 0 PCB that we have seen at the beginning of the video is this reworked area with the yellow bodge wires. Basically, this modification is buffering the clock signal that generates the CKPVI clock with an unused logic gate. Then, this other part of the modification cuts the trace that goes to the three PVI IC clock inputs and uses the buffered signal to feed these inputs. However, in this way, only the PVIs get the delayed clock, and all the rest of the board gets an undelayed clock as the delay capacitor is now disconnected from the rest of the clock line that has been cut. So I've decided to undo the modification, and I've disconnected the buffer gate, and then reconnected the trace that was cut. This brings back this clock signal in the exact configuration of the later revision game PCBs. But the glitch is still present. At this point, I was going to declare this board unfixable, but I decided to make a last visual comparison between a working board and this /0 PCB. This capacitor on pin 6 of 8C looks like it's missing on the early PCB revision. Let's see the schematics. That is the capacitor in the red circle here. The value on the schematics is about twice the value I found on the working boards, which is 4.7 nanofarads. Its function is to delay the opaque signal to the CPU after every access to the three PVI ICs. Now, we have to keep in mind that the S2650 uses an asynchronous bus handshake. In other words, it needs an operation acknowledge signal to be asserted low by the addressed device in order to terminate the bus cycle. In this case, it seems that this signal needed to be delayed whenever the PVIs are accessed. So, if this delay is missing, the CPU could terminate the bus access cycle too early and PVI ICs could misbehave. In fact, on the revision 0 PCB, there is no capacitor on pin 6 of the 74LS10 output, not even on the other side of the PCB. I think this explains a lot. So I added a 4.7 nanofarads capacitor between pin 6 of the LS10 output and ground. Let's see if this finally solves the fault. And look at this! No more jumping aliens! This board is now electrically identical to the /1 PCB. I'm not sure this board even worked properly. Basically, they were trying to delay the PVI clock when in fact the problem was the PVI opaque bus termination signal. At this point, I've also soldered the replacement transistors for Q1, Q2 and Q3. I'll now go quickly through all the input and sound tests, hoping nothing else is broken. And yes, all the inputs worked fine. The game runs without issues and it didn't develop any new fault for a reasonable amount of time now. I think I can declare this arcade PCB fixed. So, I hope you enjoyed this rather unusual troubleshooting by comparison between an early and late revision of the same game, and I hope you learned something. If you have any question, please use the comment section below. It's all for now. Have a nice time and thank you for watching.